Thank you, Dr. Egbu, for that very kind introduction. And I'm delighted to be presenting as part of the ASEM Academic Partnership webinar series and giving this presentation from across over in the UK. And was really nice to see people kind of dialing in and logging on, of course, from parts of America, but from many countries around the world, including parts of Europe and Asia and other parts as well. So that's great to have international attendees. So yes, the presentation today is all about harnessing engineering management for sustainable development. And what I'd like to do in terms of the contents of the webinar then, I thought it would be useful to start off by giving some background on the landscape, the kind of wider challenge that we face and kind of using that as an introduction to sustainable development. And then I would like to consider how we can use engineering management or parts of engineering management to focus in exploring two different areas, which I'm positioned here as kind of mini case studies. One of them is around measuring the impact of infrastructure projects on the sustainable development goals. And then the second one focused on assessing the viability of renewable energy sources through using a method called techno-economic analysis. And then I'll finish off with some final thoughts. And so I'm conscious to keep this to about 40 or 45 minutes. So diving straight in then and thinking about the background to the wider challenge, just to kind of set the scene as a lead into the concept of sustainable development. Now, of course, we will all see on the news, dare I say almost on a daily basis, the impact that we're now seeing of global warming and climate change. And you can see some very, visually striking images there from NASA, wildfires, which I know, occur, for example, in parts of California, droughts across the world, and, storms and increasingly more severe, weather activity and more harsh weather. Indeed, I think in the UK, we had the hottest year ever this last year. And of course, around the world, many places are contending with droughts and the impact of global warming. So we can see it in a very clear way, the impact of climate change, which is a key kind of factor to consider in terms of sustainable development. This is another interesting image, which I think, again, is clearly visible. And you can see the image here of this place called Pederson Glacier in Alaska's Kenai Mountains. And the image on the left is from 1917, a long time ago. I should say that I didn't take that picture myself, not quite that old. But then about 90 years later, we see an image of the same part. And very clearly, the glacier has shrunk and kind of pulled in almost just into the mountain area. And we're left, instead of seeing glacier, really just seeing grassland there. So that's a very visible impact of global warming. The glacier, the ice has melted. That would be contributing to rising sea levels, as well as an expansion of the actual body of water, the sea as well. So kind of double contribution there to rising sea level, which would have, will have a big impact in areas, low-lying ground kind of areas. Now, there is a lot of data that's showing the increase in global temperature. I think it's fair to say it is a theory that the global average temperature is caused from the burning of fossil fuels, but nevertheless there is a lot of very strong data to support that it is through burning of hydrocarbons and the greenhouse gas effect caused by CO2 levels. You also have other greenhouse gases such as methane, which has a significant effect, but CO2 is a main driver certainly. And the current data is showing an increase of about 1.2 degrees Celsius above the kind of pre-industrial baseline from about 1850, and you can clearly show the increase in temperature or see the increase there. And kind of correlating clearly with that is the increasing CO2 productions level across the world. So back in 1950, the world was generating about 6 billion tons of CO2 per annum, and then quite significant increase up until the present day, more than 35 billion tons. A slight dip caused by the pandemic, but I understand this year will be the highest ever release of carbon dioxide into the atmosphere, and that's despite all the discussions on this area. CO2 continues to increase in emissions. A number of countries have signed up to net zero targets. So the UK and the USA, I think, have a net zero target of 2050. Other countries, a similar time frame. But really, I mean, we're looking at, having to have quite major reductions in global greenhouse gas emissions over the coming 5 to 10 years if we are to try and keep the overall increase to within 1.5 degrees Celsius. The IPCC target is to keep it within 1.5. Current projections are maybe more around the kind of 2 to 3 degrees Celsius increase. And that's if and even then, there would need to be a reduction, but certainly to stay within 1.5. Previously, the Paris agreement was for 2 degree increase, but more recently 1.5. You can see that severe reductions are going to be needed in CO2 emissions, and really quite urgently over the coming years. In terms of the solutions and potential way forward, so it's a similar graph now, but it's again looking at carbon dioxide potential emissions towards a sustainable development scenario over the coming decades. But it's increasingly likely that there'll be no single or simple way of really reaching the carbon emissions reduction goal. So yes, we need to bring carbon emissions down, but it's likely to be based on a whole range of different solutions where we have some current technologies and future technologies are also needed. We can think about efficiency in terms of the insulation in buildings and homes, more efficient transport, automotive vehicles, and of course there is a role for renewable energy, such as solar, PV and wind, biofuels. Likely to be an ongoing role for nuclear, new forms of nuclear fission in terms of maybe small modular reactors. In the medium to long term, possibly nuclear fusion, that's still under development. And then we have other kind of technology areas such as CCUS, which is carbon capture, utilization and storage, where the CO2 can be captured from burning of hydrocarbons. CO2 is then, well, first it has to be separated from the other material through a series of scrubbers or usually amine kind of compounds. Then the CO2 would be liquefied and potentially kind of pumped underground in the case of CCS, or converted into higher value organic compounds in the case of CCU. So really it's a big challenge, absolutely, but there's significant scope for kind of applying existing technologies as well as new and emerging technologies to meet the requirements here. So of course, this is a big component within sustainability, but there are other dimensions as well. I mean, there's some data here looking at the increase in the population of the world over many years now. The data is a couple of years out of date, but indeed, there is uncertainty about what the population will be in the future. Will it continue to go much higher, or will it indeed plateau and maybe go a little bit lower? I think it's now actually gone over the 8 billion mark. And I remember growing up in the 70s and the 80s, and it was around 4.5–5 billion people. and it's already up to 8 billion. So yes, uncertainty of what the population will be in the future, but nevertheless, we could think about, do we have the necessary resources, energy, and clean water, fresh water, to meet the needs of that population, of possibly uncertain growth levels going into the future. And indeed, we can also consider potentially quite significant parts of the world are still existing under the poverty line of just under $2 per day. This data is maybe a couple of years old now, but we see still significant parts of Africa, some parts of South America and Asia existing on a very modest, very poor kind of economic benefits there, and really we would say the people living in those areas do not necessarily have the economic resources to meet their needs, and in terms of their kind of social development and well-being. I mentioned water a few moments ago, so some data here from the UN, and some estimates: over 80% of wastewater is discharged in the world without treatment, and we know that dirty water can give rise to very dangerous diseases like cholera. With about 1.7 billion people living in their river basins where the use is exceeding the recharge, so you see depletion of groundwater reservoirs and aquifers there, and lots of people, over 4 billion people over the last few decades or so, subject to droughts. So I've covered quite a few areas here, but what I'm trying to demonstrate or highlight, there are these different dimensions to sustainability and the concept of sustainable development. And to try and bring things together, that there was a key kind of commission which was held back in the 1980s, and it was headed up by this lady, Gro Harlem Brundtland, the former Prime Minister of Norway. And this gave rise to the Brundtland Commission, the Brundtland Report, and it includes a very concise definition of sustainable development as development that meets the needs of the present without compromising the ability of future generations to meet their own needs. And so we could think about that, kind of just unpick it slightly. At the heart of this definition is basically what it's trying to say is that we can no longer keep consuming material if it's going to damage the ability of future generations to meet their needs. Equally, what it's also saying is that we shouldn't necessarily have to kind of stop everything we're doing, because if we stopped traveling, if we stopped visiting people that we want to visit, then we're not meeting our current needs. So at the heart of it, we've got to think about how can we change the way that we work and operate and do things while still meeting our needs of today, but without negatively impacting on future generation needs. And I think that's really at the heart of sustainable development. The United Nations put in place the SDGs and the Sustainable Development Goals, nearly 200 countries coming together to set out these goals. There's 17 goals to work towards them by 2030. And, of course, they're in very admirable areas, very worthy areas, such as no poverty, reducing hunger, having clean water and sanitation. So I don't think we would argue with these SDGs, but we may say, well, how are we going to achieve them? How do we know that we're achieving them? And is it realistic that we will achieve all the goals by 2030? So there is a lot of work to be done. And indeed, there's quite a bit of complexity behind the SDGs themselves. So there are 17 SDGs, but there are 169 targets and 244 indicators. And so this is from goal 7 to, and this example is about providing affordable, reliable, sustainable and modern energy for all. And we can see here, for example, a target 7B, which would be to be by 2030 to expand the infrastructure and upgrade the technology for supplying modern and sustainable energy services for all developing countries, et cetera, et cetera. And then we see an indicator 7B1 there, installed renewable energy generating capacity in developing countries in watts per capita. So that seems like a good numerical way of trying to measure the achievement of sustainable energy within developing countries. We could measure that, but I think we could probably say that across the world, all the developing countries at the moment, I would suspect, do not have access to all their energy needs at the moment, and probably certainly not from a renewable renewable energy source. But that gives you an indication of the kind of the level of detail that sits under the SDGs themselves. One of the aspects about the SDGs as well is that you sometimes can have feedback that can kind of impact achieving one SDG as a consequence of pursuing on a first one. And what I mean from that, for example, on the one hand, achieving one goal may contribute positively to another goal. So pursuing goal 2, enhanced food security, reinforces poverty eradication, goal 1. So that would be a positive kind of reinforcement. However, the converse is also true. So sometimes pursuit of one target may conflict with another. So an increase in agricultural production to help end hunger, goal 2, may result in an increase in water use, which is then competing with water demand for achieving universal access to drinking water, goal 6. So so there is kind of issues here. It's not as straightforward or simple as just pursuing all goals uniformly, because you may potentially negatively impact some goals as a consequence of pursuing specific ones. So there's an interesting tool mentioned at that website that allows you to consider these points. This is a nice depiction that has been published by authors Rockstrom and Sukhdev, and I think we could all recognize, maybe most of us recognize, the image of a wedding cake there. Maybe normally wedding cakes are not quite as colorful as that, but the idea is to depict the SDGs across these 3 levels. And the concept is that we can pursue positive developments in terms of those SDGs aligned with the biosphere. That's a part of the world where there is life, whether it's life on the land, underwater, as well as tackling climate action. That becomes a solid base. Then once you're generating positive developments there, then to pursue the SDGs at the societal level, once you're achieving performance there, ultimately then contributing to developments in the economy. So I think this is an interesting way of organizing the SDGs. And indeed, many organizations do cluster SDGs according to their own needs, and that includes industrial companies. There are other frameworks for considering sustainability. So the ESG framework is more from the financial investment community, and it's increasingly used by investors to consider the status of industrial companies according to these 3 areas. So what kind of activities do they have that impact on their emissions? How do they manage water? What are their recycling processes? The environmental? What is the social impact in terms of how they treat their employees and diversity, and how these areas are governed, and the ethical dimension? So the ESG framework is there and increasingly is considered, yes, as part of investment cycles. There are other standards as well. A well-known standard are the ones, the GRI standards. These enable companies to report their business activities against the economy, the environment, and the people dimensions. GRI has been running for a significant amount of time, and there is a whole series of guidelines available, protocols as well, so that companies can measure their kind of impact in a consistent way. And there's also guidance for companies from different industrial sectors. So this is equivalent to the SDGs, but nevertheless there is the own terminology, structures, and kind of metrics associated with the GRI. But nevertheless, we could say that it is an equivalent framework maybe for compared or running alongside the UN SDGs. But yes, I mean, hopefully I've given you different perspectives on sustainability. I think maybe my final slide in this section is to highlight another emerging concept associated with sustainability, which is the circular economy. And the idea here is to extend product lifespans through designing and kind of recommissioning material and products. Really, the concept is to move beyond just recycling, although that is part of it, but to use renewable energy, green products, and also to have remanufacturing. So, for example, possible applications could be, old tires from cars or from automobiles being used in construction materials, or maybe taking the circuit boards from computer equipment and remanufacturing them into different devices and different machines, or possibly reuse of battery materials from electric vehicles. That could well be a big circular economy application of the future. So this would also be a sustainable approach that we could consider, and is definitely an active area under development. So hopefully I've given you that kind of overview of sustainable development now to give you a flavor of the different dimensions. And so I wanted to think about how can we use the discipline of engineering management then to help us investigate some key areas of sustainable development. And we know that engineering management is the study or is concerned with the management of people and projects in a technological or engineering systems context. And it also provides a lot of tools and techniques to analyze and evaluate complex situations. So can we use EM as a lens, as an analogy of a lens to look at sustainable development? And I found this text from the engineering management body of knowledge. There is a section there on sustainability, and you can see the text there. It mentions key developments such as the Brundtland report that I mentioned earlier on, as well as something that the Stockholm conference as well. And it goes on to the following page. So certainly sustainability is mentioned in the engineering management body of knowledge as something important, in the context of engineering management. And so moving on now to think about that, the first case study then, and this is measuring the impact of infrastructure projects on the SDGs. And I think this would relate definitely to the Ian Bock Domain 5, because it's very much focused on project management. We can revisit the SDGs here, and we've seen that diagram before. So we know that there are 17 of the SDGs, there's the 169 targets, 244 indicators. Now, but the SDGs were developed as an international framework, and the targets are really at, at a country or national level. The question arises, how do we translate then these SDGs into measurable activities at the organizational or even project level, so that then we could try and measure SDG performance at that level? In this context, we can think about the case of infrastructure investment. There's some data here, maybe it's a couple of years old, but it's highlighting the projected growth in infrastructure investment across the world. These reports here were projecting between 2016 and 2040, over $90 trillion worth of investment in infrastructure. And so we can think about that as an opportunity to not only stimulate economic prosperity, but also try to pursue sustainability targets around reducing poverty, raising standards. If we could essentially kind of build in to this infrastructure development the goals of SDG and as part of that initiative. But then the question would arise, well, how would we actually know that we're achieving the SDGs? How could we measure SDG performance for infrastructure projects? And we can think about some underpinning theory and concepts in this research area. So the diagram on the right there is the very famous triple bottom line by Elkington, the concept also known as the people, planet, profit. And the idea here is that you're developing in a sustainable way, sustainable development, when you're generating positive outcomes in terms of the economic dimension and the social and the environmental, or all of three of those have to be pursued. We can also think about other theories, such as the theory of change, the concept of activities actually resulting from an input going to an activity, to an output and an outcome. It's kind of like the successive stages carried out in an action or work. And we can also think about systems theory, the need or the benefit of taking a broader or more holistic view of sustainability. So these are the kind of theories that we considered. And this was a research project by Dr. Paul Mansell, who's now graduated from LSBU with his PhD. And this research, we were able to generate a series of propositions, and they're listed on the left there. For example, P2, definition of infrastructure projects should be according to that systemic or that broader view. Or P4, we should measure SDG performance according to the triple bottom line. So we had those propositions building on the theory, and we had a mixed method research strategy based on a survey of engineers, interviews of organizations, further triangulation of the data and some case study validation as well. There's just a snapshot of some of the results here. So this was a survey that Paul carried out of engineers, 325 engineers, and we could see, where are the opportunities for measuring sustainability. So opportunities around, the role of strong leadership, a need for more education and training, and practitioners wanting simple tools or usable tools that they could use on their projects. But also big challenges. How do we actually define success? How do we know that we're making an impact on the SDGs? Competing business priorities, leadership appearing both opportunities and challenges, as well as sometimes an excessive focus on more short-term outputs rather than longer-term outcomes. And then we had data and analysis, qualitative data from the interviews of CEOs and other leaders of organizations. And so this generated a lot of qualitative data, and using a grounded theory approach and the NVivo software, it's possible to build a nodal and subnodal structure linking back to theory, and we can then assemble and capture and analyze qualitative data in order to substantiate those propositions according to the nodal structure. So not going to dwell on the detail, but just to give you a flavor of the kind of data analysis that was done on that part of the project. And bringing the work together, Paul was able to develop an interesting approach to measuring sustainability. And this is research by, as I mentioned, Dr. Paul Mansell, which was supervised by myself and collaborators, Dr. Effie Constantinou from UCL and Dr. Raul Bamidamari from the Institute of Advanced Research in India. And that's a summary, that diagram. It's really a process map that could be used to guide the identification and measurement of SDGs according to the different kind of parameters of the diagram there, which links into the different theory. And of course, there's a lot of detail behind that. Organizations can be guided as part of structured workshops and a lot of kind of gathering of data according to different dimensions of that route map. We were able to write up this research and publish it in several journals. And we also found data to support all of those propositions, either directly or through inference. What we also did is Paul was able to work with the Environment Agency and the Thames Tideway, which is a mega project in London, building a super sewer under London. And the UK government has an exercise about every 7 years where they encourage academics to submit impact case studies, it's called. And this was a case study to demonstrate the impact arising from this project. And you can see the kind of evidence that we assembled there. So a quote from the Environment Agency saying that this research would inform the measurement of sustainability across their portfolio of 5.2 billion pounds and a whole range of projects there. So this was a nice way of finishing off the project, validating through case study, and then reporting up as part of this governmental initiative across the UK. So moving rapidly on to the second case study, looking into the viability of renewable energy sources or RES through this techno-economic analysis approach. And I think this would apply to domain 4, the financial resource management, and domain 8 from the EMBOK. So in this example, we're going to be focusing on, so we're changing gear a little bit now and focusing on these renewable energy technologies, specifically solar power and wind energy, which are increasingly being adopted in many countries. And we wanted to think about, well, what structured approach, how can we analyze the engineering and the economic feasibility of installing the new renewable energy facilities for very specific cases. And the case that we looked at was the case of the country of Kuwait. Kuwait is highly reliant on the burning of fossil fuels for energy generation and water desalination. And it's been projected that if they just rely on hydrocarbons, they may not be able to meet their future energy needs. At the moment, it's very reliant on burning of oil, 47%, and gas, 53%. Hardly any use of other sources of oil, other sources of energy, I should say. But the country does have significant capacity for solar. It's part of the Middle East. Clearly, the sun shines a lot there. It's hot, and potentially also wind, and they have a 15% renewable energy target. So we wanted to investigate the adoption of wind and solar power for specific cases in Kuwait. And we adopted this techno-economic analysis framework. This is a framework, the source of it is from the website energy.gov there, but I've adapted it and added some additional materials, additional metrics here. But the main thrust of it, we have inputs, we have a specification of the renewable energy source or the case. We can do a series of technical calculations in terms of the power generation, the amount of power exported to the grid. And then we can do some economic calculations in terms of cash flow, payback, discounted cash flows. There are a number of inputs, which are in the boxes at the top and the bottom. And ultimately, it's a structured way to allow us to evaluate that given renewable energy system that we're focusing on. We decided to use the RET-Screen clean energy modeling software, which is available from Canada, the Natural Resources Canada, and this website. I think there is a free version, but there's also an expert version where a license has to be paid. Software is very good for calculating those engineering dimensions, power level calculations, as well as the economic calculations as well. So the first study was looking at wind energy. This was a project by MSc student Ali Kadja, who graduated a couple of years ago, and we were able to publish this work in the journal mentioned there. You can see the method diagram. So it's a case of defining the specific wind turbines. You build a mathematical model on the amount of power to be generated from the wind turbine. You gather certain cost data, analyze different sites. You can do further calculations and then run that through the software to do the techno-economic modeling. You can also do sensitivity analysis. And ultimately, focusing on those objectives there, how much energy could we recover? Would it be cost effective, and the potential carbon emissions possible? This is some of the kind of data that was assembled. So on the right-hand side there, we can see data for the wind speed. For example, the months of June and July, more windy in the country, high level of wind. And then looking at different sites, we can see the site of Al Amadi having a higher average wind speed. So that was the site that was selected. You're able to select the wind turbine specification, plus also input various other factors, such as a capacity factor, tends to be between 20 and 30%. So we took a conservative view there. So you then able to, you do some of the calculations offline, and you assemble some of the data from published sources. And the benefit of the software is it has some more preset kind of data points in there as well. And this is the results from the study. So we found that a wind turbine farm could be developed at a price level of about 5 cents per kilowatt hour. This would be for a 105 megawatt facility, basically 50 wind turbines. We identified the location, the initial investment there, the ongoing operations and maintenance, and the level of electricity which could be supported, as well as you're able to calculate, crucially, the carbon emission, the reduction in greenhouse gas emissions, and a payback period as well. It was a simple payback, not a discounted, but nevertheless, you can calculate all those factors for this specific case. That was the first part of it. There was another part where we were looking at solar power this time. So there was one study on wind, and this was by former MSc student Yaqub Al-Tawaini, and he also graduated, and we were able to have this work published. Again, looking at Kuwait, and this time the idea was to consider a 100 megawatt facility, whether it would be either CSP or PV. So traditionally, we think of solar power as photovoltaics, often silicon-based, and conversion of solar radiation to electricity through the PN junction within the silicon material and the movement of electrons. There is an alternative system, the concentrated solar power, which uses mirror configurations to drive a heat engine, essentially a steam turbine, a more traditional energy generation thereafter. And this was a study to look at comparison of those two different types of power plants. Again, excuse me, we're able to generate or assemble a number of assumptions here, and we were able to select a 100 megawatt facility. We were able to assemble kind of data inputs from different sources. So as I've mentioned, some of the data you have to find, some of the data you're calculating offline, and the software also does provide some data. And then in terms of the kind of results, we see some charts there on the right-hand side, their payback, cash flow kind of charts. And the study really found that CSP, this concentrated solar power, would have a payback of over 10 years and a net present value of about $300 million, whereas PV much shorter payback, about 3.5 years at a slightly higher NPV. Also calculated the internal rate of return, other factors that are mentioned in the chart there. So you're able to then, for this given case of considering Kuwait for a 100 megawatt facility, able to recommend that it would be, the more suitable would be the PV power plant. And we also calculated the potential carbon emission reduction also arising from that project or that investment. Okay, so I accelerated a little bit there to make sure that we'd stay on schedule. Just a few more slides remaining, I think. This is just to update you. More recent research we've carried out, applying the techno-economic analysis approach, but looking at the interesting case of what is known as photovoltaics. The idea of taking photovoltaics floating on a body of water. You potentially have a cooling effect of the solar panels, which may potentially increase the efficiency. So that's a study we've just completed, and we're actively pursuing further projects this year as well, looking at really quite different applications of the TEA modeling approach to different renewable energy sources. Okay, so time to kind of just finish it all off and give a final few thoughts and comments. Well, hopefully at the beginning of the webinar, I tried to emphasize that, of course, greater effort and indeed a more transformative effort is needed across the world if we are to realize the worthy goals of sustainable development. And that is acutely the case, absolutely requiring urgent action in terms of tackling climate change. We have the SDGs as a framework for measuring sustainability, but there are other frameworks as well. There is the ESG, there is the GRI, and indeed there are some other approaches. They each have their own merit and complexities as well, and are being adopted in different countries and organizations at differing levels. I think, in a lot of these areas, we do have access to some existing technologies, but we still need new disruptive technologies to be developed, and potentially in combination with new business models alongside those technology adoption. That's essential if we're to get anywhere near those net zero targets and kind of carbon neutrality in terms of tackling climate change. Hopefully I've demonstrated how engineering management, I think, is ideally suited to tackle the science, technology and engineering challenges of sustainability, including EM domains such as project management, but absolutely others as well. I've spoken a lot about tools, techniques and processes, and that's of course required in terms of engineering, but ultimately of course I think it's people coming together with a shared objective, access to those tools. Yes, that's needed then to meet the ultimate goals and challenges of sustainable development. So thank you everybody for listening today, and just about kept that within 45 minutes, 40 or 45 minutes, and happy to take any questions that we have. So I think I could probably stop sharing.
Thank you very much, Dr. Philbin. We have some questions in the chat, and just to remind everybody, we've had some great comments and questions so far in the chat, so keep submitting questions for Dr. Philbin. So our very first question is from Marilyn Spink, and she has two questions. The first question is there a case study to look at the entire greenhouse gas footprint in the supply chain of the materials procured?
Right. So measuring greenhouse gas emissions for supply chains, it's an interesting area. I'm not aware of a framework that could be used. I mean, I actually attended another webinar yesterday, and it was a webinar by the people that organized the GRI, and they had a couple of industrial representatives who were definitely considering their emissions and sustainability in terms of their individual value chains. And when they said value chain, they meant their supplier base, and so the supplier base as well as the company itself, and indeed the user, the community, the kind of customer of their products and services. So it is something that I think some within companies, their proprietary information with industrial companies, it is something that is being looked at. In terms of a readily available model, I'm not sure of a specific framework for measuring across the supply chain, but I think it's an interesting area to tackle.
Thank you. The second question from Madeline is, in the Kuwait study, the energy sources also do not eliminate the need for fossil fuels, as it's intermittent unless they have energy storage capabilities. Was energy storage part of the project?
Yes, I'm trying to think back. Did we include specification of batteries? I'd probably have to double check the publications now. But I completely take the point that if you were going to be completely reliant on renewable energy sources, then you absolutely have to specify kind of energy storage. And indeed, many approaches really are thinking about renewable energy, wind and solar as a complement to a more reliable energy store or energy generation area, possibly nuclear. Certainly in the interim, across the world, we're still burning a lot of natural gas. Maybe it's cleaner than coal, but it at least is a lot more reliable. Potentially, if you are burning natural gas or hydrocarbons, then you can think about carbon capture and storage, CCS, fitting that to a power station. But nevertheless, I think it's a valid point that you do absolutely have to think about the reliability of sun and of solar and wind. It is not always sunny, certainly in certain parts of the world, and it's not always windy. And energy storage potentially will have to be specified as well. Yeah.
The next question is from Emmy Johnson. He's asking if you've considered doing techno-economic assessment and life cycle assessment together.
Not within an existing project. It's an interesting idea about combining those techniques. Obviously, life cycle assessment is an existing methodology, and there are procedures to go through in terms of estimating the kind of inputs to the different stages of the life cycle. But no, I've not actually looked at that. It's an interesting idea, though.
Thank you. From Michael, Michael Reddy, do you believe those of us in academia should create programs based on sustainable development and EM, or just integrate principles of sustainability in each of our courses on finance, project management, leadership, etc.? We're debating this at CU Boulder.
Right, sure. Yes, I mean, that's an interesting point. I mean, I've integrated sustainability as a lecture in a module that I deliver this last semester. And that's a module which guides students to do the planning for their research project, for their master's project. I also integrated sustainability into another module. So I've tended to go down the track of integrating sustainability into an existing program or module. I think it depends on the degree course, and is it going to be an elective or an option? I think there could well be scope for having a dedicated module or class on sustainable development. But it obviously depends on the content. What I've found certainly in terms of trying to integrate the material into existing programs for engineers is there's a lot of benefit of including kind of technology and engineering applications. emissions and avoiding it being a kind of a generic view of sustainability. And in the particular lecture that I delivered, I included a tutorial, which was very much a kind of technological based application of sustainability. So I think if you don't do that, then it's more difficult to excite the students, I found personally. So yeah, just my own experiences.
The next question, could you address the terminology CO2, CO2e, sometimes referred to all as carbon?
Okay, was it the terminology CCUS or?
So Emmy Johnson, maybe you can provide some clarification on your question in the chat. So the three terms reference here, terminology C, CO2, and CO2e.
CO2e. Did I mention CO2e?
It's sometimes referred to all as carbon. So I think it was talking about you, or just asking clarification.
I mean, I suppose, you know, if you're thinking about burning of fossil fuels, then it's producing carbon dioxide. You know, so the molecular formula is CO2. But I think it's really just, we broadly say carbon emissions, and when we would say carbon emissions, we would actually be using that as a term equivalent to the emissions of carbon dioxide. So yeah, maybe that's slightly confusing. But when people say carbon emissions, it's not actual kind of just atomic carbon. They just mean CO2, which is released and, you know, it becomes a greenhouse gas thereafter.
So the next question from Kieran, do you agree that recycling is one of the significant aspects for a sustainable future?
Absolutely, yes. I mean, we can think about recycling in terms of, you know, even the refuse that is generated from our homes. I live in London, and we have to recycle, you know, paper in one collector, cans and plastic and stuff from the garden. So it's already separated into multiple areas. And I think that strategy over the last decade or so has helped a number of countries to reduce the amount that goes into landfill, and then we can recycle more material. For example, a lot of oil is you know, oil which is cracked to produce carbon compounds, which are then ultimately polymerized into producing plastics. So the more that we can recycle plastic materials, then basically we're going to use, you know, less hydrocarbons. So I think, yes, recycling is the first level where possible. Then can we build on that through this concept, slightly more emerging concept, the circular economy, and some interesting applications where you even take existing machines and devices, and rather than throwing them away, to actually take them apart and remanufacture them, to put them into new devices, but based on existing components. And so there's interesting work being done on that. And I think that could well be a much more of an emerging application going forward, the circular economy.
Thank you, Dr. Philbin, for a very interesting presentation. There's a lot of comments that I cannot get to in the chat. There's one particularly about adding a new domain in the MBOC that is focused solely on sustainability in engineering management. So there are lots of great comments about that. We're almost out of time. So thank you very much for your presentation, and thank you to everybody for taking the time to join us from around the world. Before we end the webinar, Dr. Philbin, do you have any closing comments?
Just to say thank you, Dr. Egbu, for the opportunity to come along and speak virtually in the webinar series. Really appreciate that. And yeah, also thank you to everybody for logging on today. Appreciate that, and great to see actually all the comments provided there. I could try and maybe we could try and take note of them somewhere. Great to see the kind of points and the kind of thoughts being stimulated there, and I think that's a reflection really of the importance and the topical nature of sustainability, that it's also something that we can all engage with. Absolutely. So thanks again for the opportunity, Ona. Thanks.
Thank you, everybody. Have a great day or evening, rest of your day, depending on what part of the world you are in. Bye-bye.
Okay, bye. Thanks, everyone.
Bye.
Cheers. Thanks, Ona. Bye.
Bye. Thank you, Simon.